Welcome back to another lesson. In this video, we are going to look at an exam that was tested in April 2023. As you can see, this is April 2023, and our focus is on question on linear programming, and it was question number 7. Now, you are told that the linear programming problem has been formulated as below. The objective function z is 14x plus 10y, and then you have subject to 4x plus 3y is less or equals to 40, 2x plus y less or equals to 100, y is less or equals to 50, x, y greater than 0. Required, get the optimal production for x and y using the simplex method. Now, here, the first step to do here is to convert the inequalities into equation. We do what? Convert the inequalities into equation. Convert the inequalities into equation by introducing slack variables. By introducing slack variables. Now, we shall have, since you have 3 equations, we shall have 3 slack variables, and therefore our objective function becomes this is 14x plus 10y. This is 14x. This is 14x plus 10y plus 0s1 plus 0s2 plus 0s3. That is our objective function. Now, first equation is 4x. Let the slack 1 be for the first equation, and slack 2 be for the second equation, slack 3 be the third equation. Therefore, the next equation, here we shall have 4x plus 3y plus s1. Here we shall have 4x plus 3y plus s1 is equals to 240. 4x plus 3y plus s1 is equals to 240. Here we have 2x plus y is equals to 100. Here we shall have 2x plus y plus 0, s1 plus 0, this is s2. In fact, here we don't have to introduce those ones. Let's just call this one s2. S2, this one is going to give us 100. 2x plus y is going to give us 100. Then this is y plus s3. Y plus s3. Y plus s3 is going to give us 50. Y plus s3 is going to give us 50. Good. Now, here we have introduced our slack variables. We need to come up with the initial simplex table. Come up with initial simplex table. Now, with our initial simplex table, we need to draw the table like this. Here we need to draw the table nicely. We need to draw the table nicely. We need to draw this table nicely. We shall have our contribution. We have our basis. Then we have our x, y, slack 1, slack 2, slack 3. We have value, or we call this one bi, and then we have ratio. In this initial table, there is very little to be done because we are just copying the values as they appear in our equations. Yeah, here we are just copying values. The basis here we shall have slack 1, slack 2, slack 3. We need to have Cj. We need to have Zj, and finally Dj. Slack 1, the coefficient of this initially are all 0, 0. They are obtained from the objective function. The coefficients there so from the objective function is 0, 0. From here, 0, 0, 0. X, we shall have 4, 3, then S1 is 1, the rest are 0. And then B, this is the value you have been given as 240. S2, I'm just copying the equations as they appear here. This is 2, 1, S2 is equals to 100. Here I'm going to have 2, 1, then 0, 1, 0 is equals to 100. And finally, here we don't have X, so it's 0. We have Y as 1, and then we have no S1, no S2, S3 is 1, and the total is 50. Cj, initially they are supposed to be as they appear in the, and in fact Cj don't change. Cj will be as appear in the objective function. 14, 10, 0, 0, 0, 0. Zj, initially they are all 0. Why do we say they are all zeros? Because for you to get Zj, you need to multiply them with the contribution. Having noticed that the contribution is 0, if you multiply anything inside here by 0, the Cj will be 0. Now, next, we need to find the Dj. Dj here, we are going to have Cj minus Zj. If you want to find Dj, is equals to Cj minus Zj. So here we are going to have, this is 14, 10, 0, 0, 0, 0. Now this is called initial simplex table. We need to do something here. One is to test whether it's optimal. Test optimal. To test optimal, we look at Dj. Is it 0 or less than 0? The answer is no. Because here I'm having 14, I'm having 10. So I notice that the table is not optimal. We move to the next stage. The next stage is to identify the key column and the key row. Looking at the Dj, the one with the highest value here becomes the key column. This one becomes the key column. Now, on top of this key column, there is something we call X here. This X becomes the incoming variable. Incoming variable. Now, I need to divide the value with the coefficients in the key column. Here, what is 240 divided by 4? I get this is 60. 100 divided by 2, I get this is 50. 50 divided by 0 is infinite. Any number divided by 0 is infinite. Very big, you can't know the answer. So I pick the minimum value here. And once I pick this minimum value, it's going to give me the key row. And where they are going to intersect here, they are going to give me the key element. Here, they are going to give me the key element. Key element. Key element. Key element in this case is 2. The key element here is 2. Now, it therefore means below or behind the key element, there is what we call outgoing. outgoing variable. This is outgoing variable. We are going to replace this one with the incoming. The incoming is supposed to be in that. Now, having identified this, you move to the next stage and you look for second, just write second simplex table. Second simplex table. Here, I still have my C, my contribution. I still have my basis. I still have my X. I still have my Y. I still have my S1. I still have S2. I still have S3. I still have value or BI. I still have ratio. This is our second simplex table. Now, what do we do here? The basis remain, but one has already gone. The S2 is being replaced. S2 is outgoing, is being replaced by S2 is being replaced by X. So I will have S1. I will have S1. I will have X, S3. Then once you are done with S3, what followed next is CJ, ZJ, and DJ. I have my CJ. I have my DJ. No, not DJ. ZJ first. You have my ZJ, ZJ, and finally DJ. Now, I hope up that point we are together. I'm creating another table here. The coefficients S1 will still be 0. The coefficient of S1 will still be 0. The coefficient of X in our, you go to our inequality. The coefficient of X is 14. The coefficient of X here is 14. The coefficient of S3 is 0. Good. We have the coefficients of our bases here. We go to the key row and we have identified what we call the key element. So we divide each and every item in this row with the key element. So it will be 2 divided by 2, 1 divided by 2, 0 divided by 2, 1 divided by 2, this divided by 2, this divided by 2. Can we do that? Okay, 2 divided by 2, it is going to give me 1. 1 divided by 2, give me 0.5. 0 divided by 2, give me 0. 1 divided by 2, give me 0.5. 0 divided by 2, give me 0. And 100 divided by 2, give me 50. We are together up that point. I hope we are together up that point. What have I done here? I've said I'm going to the key row, pick the key element, divide the items inside this key row with the key element. Now, the task is to fill S1 and S3. Now, if you want to fill S1, row, there is some mathematics here we have to do. If you want to fill S1 row, there's some mathematics here we have to do. We have to identify the odd row element minus new row elements multiplied by the balancing figure. Odd row elements are the one in our table number 1, S1. 4, 3, 1. We have, this is 4, 4, 3, 1. Odd row elements are the one in our first table. Here, 4, 3, 1, 0, 0, 240. 0, 0, 240. You can see here up to the value, 0, 0, 240. We have 0, 0 to 40. Here, we minus the new row elements. The new row elements we have are the one I've picked here. 1, 0.50. We have 1, 1, 0.50. 1, 0.50. Then 0.5050. Then 0.5050 times the balancing figure. Times the balancing figure here. You need to pick these values nicely. Once you mess them up, they will give you wrong answers. 0.5050. Correct. Now, balancing figure. What is balancing figure? The balancing figure, you move to the key column and the point where it coincides with the row of interest. Key column is 14. Point here is 4. So our balancing figure is 4. I hope you can see that. This is our balancing figure, 4. So I multiply this one by 4. This one times 4. Our balancing figure is 4. 4, 4, 4, 4, 4, 4. What do we get here? We have 1 times 4. 4 minus 4 is 0. This is 2 is 1. 1 minus 0 is 1. 0 minus, what is 0.5 times 4? That is 2. This is negative 2. 0 minus 0 is 0. 50 times 4 is 200. 240 minus 200 is 40. This will be the value in our new S1. This will be 0, 1, 1. I have 0, 1, 1. Then I move to negative 2, 0, 40. Negative 2, negative 2, 0, 40. Good. I need to look for the values in row 3. We need to do some workings here for this is S3 row. S3 row. I still need to do the same. Old row elements minus new row elements multiplied by the balancing figure. Let me pick the old row elements for S3 from the previous table here. 0 here. 0, 1, 0. This is 0, 1, 0. Then 0, 1, 0. 0, 1, 0. Then 0, 1, 50. 0, 1, 50. 0, 1, 50. Minus new row elements, which is 1, 0.5. I'm just copying the same figures that are in the previous working because they see the same. This is 1, 0.5, 0, 0.5, 0, 50. Times the balancing figure. We need to look at the balancing figure. Go to the key column, and look the point where it coincides with S3. Wow, is 0. It is 0 here. This 0 means that everything here we are going to multiply by 0. And once you multiply by 0, it means that all those figures which are in our new row, all those figures in our old row will come back because this particular end here is multiplied by 0. Here I'm multiplying by 0. So I'll bring back those figures which were in old row element, which was 0, 1, 0. I will bring them back. This was 0, 1, 0. And then 0, 1, 50. 0, 1, 0, 0, 1, 5, 0, 0, 1, 5, 0. Good. CJ we said remain the same. CJ remain the same. That is 14, 10, 0, 0. This is 14. CJ 14, 10, 0, 0, 0, 0. ZJ, it requires some maths. Here needs some maths. We need to have what? We need to have the contribution multiplied by the values inside here. The first one is 0 times 0, 14 times 1, 0 times 0, this give me 14. This give me 14. Here there is very little. Next one, 0 times 1, 14 times 0 0.5, then this give me 7. Here, 0 times 0, the rest, this give me 0. Here, 0 times 0, 0 times 0 0.5, this give me 7. This one give me, this give me 7. Because it's 14 times, this give me 7. Then we have, this give me 0, of course. This give me 0. What about here? What is 0 times 40? 14 times 50, 14, sorry. 14 times 50. This give me 700. This give me 700. Good. Now, how do we get dj? Dj we subtract. Cj minus zj, this is 0. This is 3. This is 0, negative 7, 0, negative 700. Good. Having filled this is our second simplex table. Having filled this, what we need now to do is check optimality. Check, is it optimal? Test optimality. You test optimality. Optimality. Is it optimal? The answer is no, because 3 is greater than 0. Therefore, this is not optimal. If it is not optimal, it therefore means we shall have another simplex table. If it is not optimal, it therefore means we need to go and come up with another third simplex table. We need to come up with our third simplex table. And in this table, we are going to have our values as they were. Here we shall have our C, we shall have our basis, we shall have our X, we shall have our Y, we shall have our slack 1, slack 2, slack 3, we shall have our BI, and then we shall have our ratio. Yes. Now, this table, in most cases, this will be our last and final table. Once we are able to work out this way, or in this kind of questions, you are expected to prepare a minimum of 3 tables, unless the inequalities are 4. So if the inequalities are 3, this is most likely our end. Now, let's figure out something here. Here, we shall call this one our key column, because it has the highest value. And our Y here will be our incoming variable. This one will be our incoming variable. Now, let's divide the BI's with the values in the key column. 40 divided by 1 is 40. 50 divided by 0 0.5, 100. 50 divided by 1 is, this is what? 50. Now, with this, we look at the minimum here, which is 40. And this is going to give us what we call key row. And where the key row intersect the key column, we are going to have the key element. Good. Now, having identified the key elements, we are now able to get our third simplex table. What we are going to do, after identifying the key element, we are going to circle this one, and this one is going to be called outgoing. This is outgoing variable. Outgoing variable is going to be replaced by incoming variable, which is y. Hope that is clear. So let's move on. The first one is going to be replaced with y. Then we have our x and s3. Hope that is clear. The outgoing variable s1 has been replaced by incoming variable y. So this is where we are. Good. Up to this point, I hope you are all together. So we look at the coefficients of x and y from our objective function. Y is 10, x is 14. Come here and write y is 10, y is 10, x is 14, and s3 is 0. Good. We have identified the key element. Correct. Key element is the point where the key row and the key column intersect. So we divide this row with the key element. Unfortunately, the key element is 1. It means all the values remains as they are. So is 0, 1, 1. This is 0, 0, 1, 1. They remain as they are because the key element is 1. 0, 1, 1. Negative 2, 0, 40. Negative 2, negative 2, 0, 40. Now, we need to do some computations to fill the rest. The rest are not done easily. They are obtained through some mathematics here. We need to come here and we want to fill row x. We shall look at odd row elements minus new row elements multiplied by the balancing figure. Odd row elements, we are obtaining them from table 2. Where do we want to fill? We want to fill x. Is that okay? We want to fill x. So we come to table 2 and check odd row elements. Odd row elements, we have 1, 0.50. This is 1, 1, 0.50. 1, 0.5, 1, 0.50, then 0.5050. We have 0.5050. Good. I hope we are clear at that point. I'm picking the odd row elements in the row of x, which are available in second simplex table. 1, 0.50, 0.5050. They are the one which have transferred them here. Minus. We are minusing the new row elements are obtained in the third table. The new row elements are for y. 0, 1, 1. This is 0, 1, 1. Then we have negative 2, 0, 40. Negative 2, 0, 40. We look at the balancing figure. This is the point where the key column meet our row of interest. The key column meet our row of interest here. It is 0.5. I hope you can see that. Key column meet our row of interest. 0.5. So we come here and find this is 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5. Let's get the new elements now. 1 minus 0 is 1. 0.5 minus 0.5 is 0. 0 minus 0.5, negative 0.5. This is negative 2. Look at this. Negative 2 times 0.5 gives you what? What is negative 2 times 0.5 gives you 1. So it is now, look at this. This gives you negative 1. Negative 1, there is a negative here. So this one gives me 1.5. Then this is 0. What is 50 minus 20 is that. These are my new row elements here. So these are my new X row element. That is 1, 0, 0, negative 0.5. This is 1, 0, negative 0.5. Then we shall have 1.50 that. 1.5, 1.50 that. Good. We move to S3. S3 will still require some mathematics here. Row S3. We need to look at odd row elements of S3 first. Let's go to the second simplex table and look at odd row elements. Here we have in 0, 1, 0. These are the odd row elements. 0, 1, 0. This is 0, 0, 1, 0. What else? 0, 1, 0. Here, this is second 0, 1, 0. Then 0, 1, 50. Then you have 0, 0, 1, 50. Now, remember the new row elements remain the same. They are not changing. Minus new. This is new row elements. This is negative. Here you have 0, minus 1, minus 1. This is minus negative 2. This is minus 0, minus 40. I hope this one was obtained from here. This one was obtained from here. Yeah, this was obtained from here. Then we look at the balancing figure. Let's look at the balancing figure. It is the key column where it meets our row of interest is 1. Wow, it is 1. So everything times 1. So I multiply this one by 1 times 1 times 1 times 1 times 1 times 1. What do I get? This is 0. This is 0. This is negative 1. This is 2. This is 1. This is 1. And this is 10. I bring them to my equation here. This row becomes 0, 0. And then we have negative 1, 2. Negative 1, 2. And what else? Negative 1, 2. Then 1, 10. Then 1, 1, 10. Good. Having filled this table like this, we need to move to Cj. Cj, we said they are not changing Cj. Cj remain the same. 14, 10, 0, 0, 0, 0. Zj will require some calculations. What is 10 times 0? 0. 14 times 1? 14. 0 times 0, you add all of them. This gives you 14. Yeah. This is give you 10. This will give you what? 10 plus, this is 10 times 1 is 10 minus 7. 10 minus 7, this will give you 3. This is negative 20 minus, this is negative 20 plus, this is negative 20. What is 1.14 times 1.5? 14 times 1.5. This gives you 21. So negative 20 plus 21, it gives you 1. 1 plus 0 is 1. And finally here, this gives me 0. What about this? That is 400. 400 plus 400 plus 40 times 30 is 420. This gives you 820. Correct. 820. Good. DJ, at this point DJ, we subtract Cj minus Zj. This will give me 0, 0, negative 3, negative 1, 0, negative 820. Excellent. So, at this juncture, you can be able to test optimality. having found that the DJs are all less than 0, they are 0 or less than 0, we say that we have achieved our what? We have achieved our optimality. Now, having achieved our optimality, we can get the solution for x and y. Let's get the solution for x and y. We get the solution for I want some space here, just a minute. I want some space. Now, okay, let me work it outside here. If you want to find the solution for x, solution for x, you just need to come to the table and see here. Your x here is 30. Value for x is 30. So you come here and write this is 30. What is the solution for y? Solution for y, you come here and find that your y is 40. Correct. That's what you are supposed to look for. Now, slack values for each constraint. That is part 2. Slack value, we have S1, we have S2, we have this one, we call them resource. This is resource. Here, we call this one resource. The slack values here were S1, S2, S3. Then value. Value, look at this. S1 was replaced by Y. So the value is 0. The value is 0. It was replaced by Y. S2 the same. What happens to S3? S3 at the end it had a value. Here 10. S3, you can confirm this. S3 it had a value 10. S3 it had a value 10. Good. The last part you are told shadow price. Shadow price. Shadow price. The shadow price, you come and read them at the table bottom here. The shadow price here, we have this is S1 is -3, S2 is -1, and S3 is 0. These are the shadow price. Shadow price. You come and read in your table S1, S2, S3. What do you have here? S1, I've said from the table here, DJs. These are the shadow prices. -3, -1, 0. So we include the negative, by the way. Here we don't indicate negative. This is 3, 1, 0. Yes, that's how you are to get your full marks in this question. I hope I've made myself clear. This one of the video that I've been very clear on this. So I assume that you have understood as much as I've explained it. Otherwise, it's goodbye for now. We meet in our next video.